So in this video I want to talk to you about something called higher order derivatives. Up to this point we have only talked about things above this red line. Right? We understand that there is a concept of an original function, which is called g of x or f of x or h of x or v of x or whatever name you're going to give. And a lot of times that function will also be referred to as just y. Right? So great, we've got that. Right? The derivative, we've been calling something the derivative. It's really the first derivative. There's two different notations for that. One is g prime of x, and the other notation we've sometimes seen used is this dy dx. Right? So we're aware of that. To find higher order derivatives, we just continue taking the derivative. So there is something called the second derivative. The notation is either g double prime x or d squared y over dx squared. And the second derivative just means you took the derivative and then took the derivative of that thing, right? Or you took dy dx and you took the derivative of it, right? Similarly, there's a third derivative, a fourth derivative, a 17th derivative, a 2000th derivative, right? What is the third derivative? It's just where we take the second derivative and take the derivative again. You can either write it as g triple prime of x or d cubed y over dx cubed. Higher than that, we stop using the prime notation because it just gets cumbersome. Like, nobody wants to write g quad prime x. So instead, we write g with a 4 in parentheses, or a 5 in parentheses, or a 17 in parentheses, to indicate that level of derivative. To get to a higher order derivative, it just means you're taking the derivative again, right? So, as an example of this, suppose that I give you v of x, right? It's 3x cubed minus 5 cosine x, and I want us to find v double prime of x, the second derivative. To find a second derivative, we start by finding the first derivative. V prime of x is 9x squared plus 5 sine x, because remember the derivative of cosine x is negative sine x, and those two negatives will multiply together to give us a positive. So great, now that I have the first derivative, I can find the second derivative by simply taking the derivative of my first derivative. So I will have 18x plus 5 cosine x, and that's the second derivative. We just found our first higher order derivative. Woohoo! Okay. And this one I'm asking us to find d squared y dx squared if y equals cosecant x. So keep in mind this is just a notation that indicates the second derivative of y with respect to x. So we'll begin by doing that. I expect everybody can tell me what the first derivative of this thing is, what the derivative of cosecant x is. And actually, I'd like to use the different notation. I'd like to call this dy dx. So the derivative of cosecant x, we know that that's just supposed to be negative cosecant x cotangent x. So there it is, the first derivative. Now, if I want to find the second derivative, d squared y dx squared, how am I going to do that? Well, this is a product rule. There's a negative cosecant x and a cotangent x. So to do this derivative, I'm going to have to take turns letting it be the derivative. I'm going to have to do the product rule. So the derivative of the first thing, derivative of negative cosecant x, is now actually positive cosecant x cotangent x. And then I leave my cotangent x alone. Then I have plus, I leave my negative cosecant x alone. And the derivative of cotangent x is negative cosecant squared x. And now all I have to do is go through and pretty this up a little bit. D squared y dx squared is cosecant x times cotangent squared x plus cosecant, I just realized I missed a c up there, cosecant cubed x. And if I wanted to simplify this thing, I could factor out, it looks like I can factor out a single cosecant x times cotangent squared x plus cosecant squared x. And that's my second derivative. I'll mention at this point, by the way, some of you have gotten into the bad habit of not writing next to the expression what it is that you're working with. Now that we have higher order derivatives, it's always been important, but it's even more important that you label what things are. Like, it's important that up here at the top, I knew that this thing was an original function. that this was a first derivative, and each one of these things was actually a second derivative. Right? So if you haven't already gotten into that habit, please, 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 every line that you're writing down, make sure that you're writing down what the thing is that you're working with. So my final example, I want us to find the 14th derivative of h, and you may already be crying, but wait, if I give you what the 13th derivative is, right? So I'm asking for the 14th derivative, I'm giving you the 13th derivative. Hopefully you recognize what that means. Hopefully you recognize that this is really going to be a simple problem. If I've already given you the 13th derivative, I just need to take one more derivative, right? So to find h14 of x, I'm just going to have to use the quotient rule on this thing. Now, this really is just an excuse for me to get you to practice the quotient rule again and to recognize this stuff about higher order derivatives. So pause the video, work through this one on your own, and I really want you to carefully work through simplifying that. So do that now. So I have low d high minus high d low, square the bottom, and away we go. It's worth mentioning here, these two things will pretty much never cancel out. Like, unless one of them also shows up over here, you can only divide things out of this if they are in all three of these terms. And that 2x minus 1 is not. So please, 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 like, resist the urge to cancel those out. There's really no reason to do that. So as I simplify, the 14th derivative of this thing is 2x minus 1 minus 2x all over 2x minus 1 squared. Alright, so we see here that the 2x minus the 2x will add up to 0. So I end up with the 14th derivative, 14th, being negative 1 over 2x minus 1 squared, and there it is. Alright, so higher order derivatives, quotient rule, start processing that stuff and get it stuck in your heads.